All right, welcome to week 3 of rational equations. We're actually week 29, right? But we're going to be doing this another week, you guys, just so we can make sure that we have it down. So if you would copy number 1, we're only going to do 4 examples in this video. I'll try and make it quick. But as we progress through this topic, you'll see more and more that we'll have things in the denominator that have 2 terms like this, a binomial or even larger, which we will have to factor. So let's do that. Let's take this and factor. That is always going to be our first step whenever we have to solve an equation like this. We need to find a common denominator. So 2x squared minus 6x, let's write that off to the side. So this will be GCF factoring. 2 terms, we can GCF factor. So what can we pull out of both? Well, we can pull out a 2 from here and a 2 from the 6. So we're going to divide both of those by 2. And then what else can we divide? Extend the fraction bar a little bit. We can take out an x from both of them. Got an x here and an x there. So we're going to divide out a 2x. So how would that factor? 2x, parentheses, and then our 2's cancel. And we have one x canceling. We have one left. And then we've got minus sign. Don't want to lose that minus sign there. X is canceled here, but then we have 6 divided by 2 is 3. So there we go, folks. That's the GCF factored version of this thing here. So we're going to rewrite this and use what we just got. So minus 1 over 2x times x minus 3. Now, we can clearly see all our factors in the denominator. All right, so we need to identify all the different ones. But remember, you guys, the goal of this is to cancel out all of the denominators. So what do we need to do? We need to cancel this, we need to cancel that, we need to cancel this, okay? So what do we need? What do we need to multiply each top of these, each one of these terms by to cancel out all of the denominators? Well, we need to multiply it by 2x at the very least, right? So I'm going to multiply this one by 2x. I'm going to leave space for something else if I have anything else, but 2x and then 2x. Everything gets multiplied by the same thing. Now try not to get too cluttered over here. All right. Now we can cancel out this. We can cancel out the 2x here. We can cancel out the 2x here and the 2x here. But what are we not going to be able to cancel out yet? This thing right here. So because we have that thing, we're going to have to multiply everything by that as well. So x minus 3, x minus 3, x minus 3. All right, now we're ready to cancel. So let's cancel. We got our 2x's canceling. We got our 2x's canceling. And then here we can cancel out our x minus 3. However, now we have an x minus 3 up top here in this term and that term. So let's write down our next step here. We have 3 times an x minus 3. That's how I'm going to write it. Equals 1 times an x minus 3, which is just that, minus 1. Okay, so let's distribute this 3 here. 3 times x is 3x. 3 times negative 3 is negative 9. So we got 3x minus 9 equals x minus 3 minus 1. Keeping track of our equal sign right there, very important. Okay, so let's first combine stuff that we can combine. We can combine something on the right. We got negative 3 minus 1. Don't say 4. Don't say 2. It's negative 4. Then we got 3x minus 9 here. We'll just copy that down. Now we got to move stuff over. We got to get all the variables on one side and then all the numbers on the other side. So how do we move things over? Well, we got to do the opposite operation, whatever it is. So we'll take away the x, take away the x, and we're left with 2x. So yeah, yeah, I'll write it here. I'm just getting a little crunched down here for the next problem. Typical. 2x minus 9 equals negative 4. And I'm going to take this up here where I have some space. And I'm going to finish off this problem. I'm going to take the 2x minus 9 equals -4. I'm going to take this -9, move it over to the other side. How do I do that? I do the opposite. Add 9. Add 9. It goes away, see? 2x equals -4 plus 9. Don't say 13, okay? -4 plus 9, that's the same as 9 minus 4, which is 5. And then we simply divide by 2 on both sides. X, these cancel, x equals 5/2. And we're done. All right. I'm going to downsize this a little bit so I don't encroach on the next problem. Okay, I'm going to try that again. Okay. Copy it down. So again, we have some binomials in the denominators here. So we have to factor these. So let's do that. N squared plus 3n. How can we factor that? Well, what can we divide by both? We divide out an n and an n. So we'll have an n here, and we'll have an n, one n left over, and then this n cancels there with a 3 left over. So we're going to rewrite both of these, because they're the same, as our factored version. So 2 over n times n plus 3 plus 1 over n plus 3 equals 1 over n times n plus 3. All right, now you can see what we need to cancel in the denominators. We have an n plus 3. We always want to see it in terms of its factors, right? We don't want to leave it like this. We have to factor it. So we need to cancel an n and an n plus 3. That's it. That's all the unique factors we have. So I'm gonna multiply each top here by n times n plus 3, n times n plus 3, n times n plus 3. Same thing on each term. Okay, now we can cancel, 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 cancel. Oops, we only cancel the n plus 3 there. And then here we cancel the whole thing, Okay, remember that's left over there. Okay, so we got 2 plus n times 1, which is just n, but I'll just write it so you can see, equals 1. Wow, that's pretty simple now, isn't it? 2 plus n equals 1. So we just subtract the 2, subtract the 2, n equals 1 minus 2. Don't say 3. 1 minus 2 is -1, guys. There you go. Okay, number 3. If you need to pause for a second, pause it, but we're moving on. Okay, number 3. Now we have some trinomials. Now, whenever we have trinomials like this, we have to factor. We have to factor. Must factor this. Okay, can't leave it the way it is. If we can't factor it, then we're just going to have to take this and multiply it by everything else, and that's our common denominator. But we can factor this. Can you? I'm going to let you try to do that. Okay, assuming you've tried, we've got m squared minus 4m plus 4. What are the two factors of 4 that add to 4, and both of them are negative? Okay, so we got two factors of 4. We got 1 and 4. 1 and 4 don't add to 4. How about 2 and 2? Those add to 4, and both of them are negative. So we got -2, -2. And then our m splits into the m and the m right there. M and m. Okay, so now we've got this basically factoring into m minus 2 times m minus 2. There you go. That's what that is. We need to write it like this. Let's do it. 2 over m minus 2 equals 3 over m minus 2 times m minus 2 plus 1 over m minus 2. Can you see what we need to multiply each term by to cancel out everything in the denominator? Well, it's going to be m minus 2 for sure. And also, the other m minus 2, we have 2 of them, right? So we need another one up there. M minus 2 times m minus 2. All right, m minus 2 times m minus 2. Perfect. Okay, so we can cancel this. We can cancel this. And we can cancel everything there, okay? And then 2 times m minus 2 is what we have left up here. So write that. It's always good to take inventory and see what you have left over. 3 right there, plus 1 times m minus 2, which is just m minus 2. So if we were to distribute that 2 right there, which is what we need to do, that'll simplify that. 2m minus 4 equals 3 plus m minus 2. What's the next step? Come on, guys. Combine like terms. Okay. Keep your equal sign there. 3 minus 2. Well, that's 1 plus m there. Bring that down. So you got 2m plus minus 4 there. Get the variables on one side. Get the numbers on the other side. How do we do that? Do the opposite. Do the opposite. Both sides. 2m minus m is m minus 4 equals 1. Add 4. Add 4. M equals 5. Boom. We're done. That's it. All right. Try number 4 on your own if you could. Okay, assuming you've tried. Assuming you've tried. Well, we were supposed to factor that now, weren't we? Yep. We got to factor that. So let's do it. V squared minus 6v plus 9. What are the two factors of 9 that add to 6 and both are negative? Two factors in it. Well, we got 1 and 9. That adds to 10. That's not it. How about 3 and 3? Yep. Those are the factors that add to 6, but both of them are negative. So it would be v minus 3 times v minus 3. 3 over v minus 3 times v minus 3 plus 1 over v minus 3 equals 2 over v minus 3 times v minus 3. All right, you can pretty clearly see this problem looks very similar to the way this one did. We just had m minus 2 up here. Same exact principle. Can you do it? Can you do it from here? Why don't you try? Okay, assuming you've tried it. Well, we just have to multiply each top by the v minus 3 times the v minus 3. That'll allow us to cancel everything in the denominators. Everything in the denominators. Okay, so v minus 3 times v minus 3, boom, those cancel. 1 v minus 3 cancels there. We're left with 1. And both cancel there. So boom, all our denominators are canceled. We've achieved our goal. Yes. Okay, now we can keep going. What do we have? 3 plus 1 equals, 1 times the v minus 3. We don't want to forget this, right? Equals the 2. So we got basically 3 plus v minus 3 equals 2. 3 plus v, or I should say these combine right here, the 3 and the negative 3. 3 minus 3 is 0. Well, that's easy. And then we got v equals 2. Oh, look at that. That just worked out perfectly. And we're done.